So in this video we're going to talk through the key concept of data types and how we can classify data as either qualitative or quantitative, and then some further subtypes that we can put our data into. So to start off with, if we have some piece of data that we've collected about a population, we can classify it as either qualitative or quantitative. So qualitative data, it comes from the word quality, and this is something that we usually measure with categories, which makes it a categorical type of data. And when I say categories, it could be words that describe the categories, or sometimes even numbers or rankings describe the categories as well. So when we talk about quantitative data, this comes from the word quantity, and this is something that we usually measure with numbers. So this is numerical data. So we can now talk about some further classifications that we can make out of these two subtypes. So if we look at qualitative first, we can classify it as either nominal or ordinal. So if I just shift down, we can get some definitions. So if we talk about nominal to begin with, this is where we have categories which have no real order amongst them. So order would mean, something is better than the other or something is higher than the other, but for nominal that doesn't really exist. So we can think of a few different examples that might fit this. One is like gender, male or female. You can't really say one is better or worse than the other, or one is higher or lower than the other. And another one might be if you asked a bunch of people for their favorite color, they're going to respond with blue or black or green or red and so on. And each of those is a category in itself, but we can't say that blue is better than red, or again, blue is higher than red. It just doesn't really make sense. So that's why it becomes a nominal piece of data. So the next one that we have is ordinal, and as the name suggests, this is going to have an order or a rank among the different categories. So we can see here from the definition, we have a natural order for those categories, but a good thing to note is that the difference in value between the categories doesn't really matter. So let me give you a couple of examples. So one of them might be if you asked people, what is their highest qualification? So they might answer back with, I've completed high school, I have a bachelor's degree, I have a PhD, and so on. So there's a definite order for those observations, because we would generally classify a PhD as a higher qualification than a bachelor's degree, and that's higher than completing high school, and so on. So there's definite order there. But the difference in value doesn't really matter as such. So we don't really say like a PhD is twice as good as a bachelor's degree. That's not really a comparison that you can make with this type of data. So that's why it's ordinal. Another example might be the race finishing order. So if you run 100 meters, whether you come first, second, third, fourth, and so on like that. That would again represent ordinal data, because there is a natural order, first, second, third, fourth, and so on, but the difference in value between the categories doesn't really matter. Are you twice as good if you come first compared to second? That's not really a conclusion that you can make from that type of data. So that's why it becomes an ordinal variable. Alright, so if we now talk about the different types of quantitative data, we can classify as either continuous or discrete. So for continuous data, what we're looking for is really that we have infinitely many values that our observation can assume. And here it's important to note that the difference in value does really matter. So a couple of examples of this might be if you ask people for their height. Okay, there's an infinite number of values theoretically that could be, and it's only really limited by the accuracy of the tools that you're using to measure that person's height. So for example, if we're using a ruler, maybe we can measure to the nearest centimetre. If you have something a bit more accurate, you might be able to get to the nearest millimetre, and again, if you keep on using tools that are more and more accurate, you're going to be able to get to more and more decimal places. So hopefully you can see then that there's really an infinite number of values that my height could assume. Another example might be the time to run 10 kilometers. Okay, again, the accuracy of this is really just dictated by the tools that you're using to measure it. Theoretically, there's an infinite number of values that it could assume though. Alright, so moving on then to discrete. The difference here is really that we have a fixed number of values that your observation can assume. And again, the difference here in the values really does matter. Let's give a couple of examples to try and make this clear. So one might be the number of bus trips that you take in a week. So when you measure this, it's really going to have to be a whole number. You either take 1 bus trip, 2 bus trips, 25 bus trips. You can't really take partial bus trips, so like 0.5 or a third of a bus trip. So since we are restricted to only measuring this in whole numbers, there's really a fixed number of values that our observation can assume. Another example might be the number of shirts that you own. This again would have to be measured as a whole number. You can't really have half a shirt, and it doesn't really make much sense. So that's why it becomes a discrete variable, because that value is fixed. So just one last thing I want to point out is really the difference here between the ordinal data and the quantitative data is that here the difference in value between the categories doesn't matter. Here it does. So I could say if I ran a race in 5 minutes and you ran it in 10 minutes, then I was really twice as good as you. It does kind of make sense to make those comparisons when you're looking at the quantitative data, whether it is continuous or discrete. So really the reason that we're talking about why we need to classify data into these different types is it's because it helps us when we need to analyze the data. Depending on what type we have different options available, and that's something that we're going to explore a bit in future videos. So that's all there is, and see you in another one.